So my last video got cut off, and I was just about to get to the end of the problem. So the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 1 is equal to 1. You can see that from the left and the right, the y values are both getting closer and closer to 1. So that would be your final answer on that problem. So now we'll move on and look at graphs or at limits graphically. And before we do that, I'd like for you to fill in a couple of statements. So the first statement, it often happens that the point at which a function is undefined is where the function has a limiting value. And you actually saw that in that example 1. And so a function may be undefined at x equals c and still have a limit at x equals c. And so we're going to look at a graph right now. And so I'd like for you to, at the bottom of your notes paper, draw a graph that has the defined point of 0, 1 and has the defined point of 3, 2. And you'll see that in my graph right here. And then a hole in the graph at 3, 4. And then you could connect the rest of the graph as I have shown and label it as f of x. And we're going to look at 4 questions about that graph. So the first question we'll consider is, what is the value of f of 3? So in other words, when x is a 3, what is the y value associated with it? Well, that would be at this point right here. And we said that that was defined to be a y value of 2. So f of 3 is equal to 2. But now I would like for you to look at the limit as x approaches 3. Well, when you do that, you have to look at what's happening as those x's get closer to 3 from the left and from the right. And so we're looking at what are the y values doing as x gets closer and closer to 3 from the left and the right. Well, the y values are on this graph that we have drawn, this continuous part of the graph. And as we get closer and closer to 3, the y values are getting closer and closer to 4. So there you're not interested at what happens at 3. You're interested at what happens before and after 3, very close to 3. And then I'd like for us to move on and consider part C. What is the value of f when x is 0? So f of 0, well, that would be this defined point right here. And so f of 0 is 1. Your y value is a 1. And then part D, we'll look at the limit as x approaches 0. So from the left of 0 and from the right of 0, what are the y values doing? Well, in this case, the y values also are approaching 1. So what I wanted to illustrate to you with these 4 examples is sometimes the function value and the limit are the same. And sometimes the function value and the limit are different. And we'll notice that that difference often occurs when the function has some kind of undefined value or something unusual happening with the graph.